7.1, solving systems of equations. Well, you should learn. You should use methods of substitution and graphing to solve systems of 2 equations and 2 variables. Use systems of equations to model and solve real-life problems. So that's what we're going to focus on. We're going to focus on specifically substitution and graphing. We'll do elimination in the future lesson. So the method of substitution is basically you want to solve for one equation in terms of the other. Solve for one variable. That's what that means. Solve for one variable. And then you can substitute it into the other equation. Then we're going to sub into other equation. And then we're going to solve. And then we're going to sub back in. We're going to sub our solution, solve the answer, back into original equation to find all solutions. That's the method. And then you should check it to make sure they both work. That's the method of substitution. You solve for one variable, sub it into the other equation, solve it, and then you have to go back and don't forget to solve for the first variable again. The method of graphing is this: you graph them and see where they cross. Solve both equations for y in terms of x. But that's the one thing you want to get put in slope-intercept form. If it's linear, if it's not linear, you always just want to get y equals. That's the way we know how to graph. Put both in terms of x, solve for y, and then we're going to graph it and see where they cross. A lot of times we'll do this with a calculator because that's the only way to get a precise answer. Anyway, let's do a quick example. So we're going to solve this system. We're going to focus on substitution and graphing. I'm not going to do this by elimination. You know, it's staring me right in the face. We're going to do by substitution. Step 1 is try to solve for one variable. And we generally try to keep it easy. I'll probably do it right here. I'm going to get x by itself. I'm going to add y to both sides. So we're going to have x equals 2 plus y. Then we're going to get that equation. And we're going to sub it back into what? This is what x equals. We're going to sub this in for x over there. So we're going to plug that into that guy there. We're going to have this now. So instead of x, it's going to be 2 plus y equals 4. Let me do that in different colors just to pronounce. So there. That was my x. And now I'm substituting 2 plus y. And then the rest stays the same. Plus y equals 4. And then we just solve. Add up like terms. We get 2 plus 2y equals 4. Minus 2 minus 2. 2y equals 2. Divide by 2, y equals 1. We start to get our x. Don't forget you need an x and a y. We're going to substitute this guy back into there, sub back in, and we're going to get x equals 2 plus 1, which is x equals 3. There's the point, 3 and 1. That's how you do it by substitution. If you're going to do this by graphing, I generally wouldn't do graphing unless it's nice and you have a calculator or something, because otherwise you're doing a lot of estimation. But for solving this by graphing, all we're going to do is solve both of them for y. So negative x plus 4, subtract x from both sides, 2 steps. I'm going to have, let me add the y and subtract the 2. Y equals x minus 2. I added y to both sides. I have this and I subtracted 2 from both sides. We have these two. And then we graph it. Let's see. First one is plus 4, 1, 2, 3, 4. Slope is negative 1, down 1 over 1. And we graph that looks. And then the other one, down 2, slope of 1, a 1 over 1. We have a graph that looks like this. And if we had a nice grid, we'd probably go, that's 3, 1. That's by graphing. Generally, you want to do that on a calculator, though, because you have to have a perfect graph to get it right. Okay. You can also do it to solve application problems. A total of $12,000 is invested in 2 funds paying 9% and 11% simple interest. The yearly interest is $1,180. How much interest at each rate? We're trying to figure out how much is invested in this percent and that percent. Let's make this x and let's make this y. We know one thing. We're investing a total of this much into each of them. If I go x plus y, it's $12,000. That's kind of the total. That's how much I have totally invested. I invested $12,000 into both of these accounts. The next one is going to be, I like to say, the value. We have a total equation and a value equation. What value am I getting? If I do my 9% 0.09 x and my 11% 0.11 y, it should equal this amount. That's the value we're getting. My amount times my interest, my amount times the amount of interest, add them up, and it equals how much interest I'm getting. We get that. Those are my two equations, two unknowns. And we're going to do this by substitution, so we're going to try to get one variable by itself. Now let's get y by itself this time. Y would equal, let's subtract x, 12,000 minus x. And then we're going to do what we did last time. We're going to plug that in for the y over here, then we can solve. 0.09x plus 0.11 times 12,000 minus x equals 1180. And from here, we're going to distribute 0.09x plus 1320 minus 0.11x equals 1180 minus 1320 minus 1320. We're going to add terms here. That's going to give us negative 0.02x equals negative 140. And then we divide by negative 0.02. And we get x equals 7,000 using the calculator. That's how much is invested in x. Don't forget to go back, figure out how much is invested in y. If we have 7,000x, 12,000 minus 7,000 means we have 5,000 and y. The correct answer, again, because the application problem, we have 7,000 invested at 9% and 5,000 invested at 11%. That's that idea. Let's do the next one. Two solution case. This is where substitution actually beats elimination, which I haven't got to yet. Nonlinear. See how this is an x squared? You cannot solve that by elimination for the most part. Sometimes you can. But this is actually done better by substitution. Substitution does this much better. Let's solve this, the two solution case. Same process, try one variable by itself. Let's try to make it y, because it also let us all this be x. So we're going to try to get y by itself. And I'm going to do it on the easier equation. So let's see. Let's subtract 2x. I get negative y equals negative 2x minus 1. Divide everything by negative 1. And you get y equals 2x plus 1. Now we're going to substitute that in for the y we see over there. Don't forget to use parentheses. So we're going to have x squared plus 4x. There's a negative there. Parentheses are very important. 2x plus 1 equals 7. And now we have to solve this normal. So we're going to distribute x squared plus 4x minus 2x minus 1 equals 7. And now we have quadratic. The basic way to solve quadratic is set equal to 0, and then factor or use a quadratic formula or the square. But anytime it's a quadratic, you want to set equal to 0. It's minus 7 on both sides. Let's also add up these terms while we're here. We have x squared plus 2x minus 8 equals 0. Right now we have a quadratic. Luckily enough, it's an easy one to factor. Negative x, 2, x. Two things that multiply get negative 8. That's 2 is negative, positive 4 and negative 2. We're going to have x plus 4, x minus 2. We have to solve it. Split, x plus 4 equals 0. X minus 2 equals 0. We get x equals negative 4. And x equals 2. Now we have two x's, which means we also should probably have two y's. So don't forget to solve for both of them. The way you solve your y is go back and sub it in. So I'm going to go back into here. When x equals negative 4, my y is 2 times negative 4 plus 1. Negative 8 plus 1 is negative 7. We have the point negative 4 and negative 7. That is one solution. And then for this guy, x equals 2. Y equals 2 times 2 plus 1. 4 plus 1, which is 5. We also have 2 and 5. Those are both our solutions. If you're wondering why, this is a parabola. If we were to graph that, I would get some type of parabola, and then I have a line. They cross at two spots. That's how it works. Okay. If we're going to solve the simplified elimination, if we notice here, when I add these two equations up, the y's will cancel out. Let's do that. 3x plus 5x is 8x. Negative 2y plus 2y cancels out. 4 plus 8 is 12. And then we divide by 8. And for some reason, we're going to get a decimal. Divide that by 4, is 3 over 2. That's my x. I still have to find my y. We're going to go back. You can plug into any one of these equations you want. Over 2 for my x. Oh, not going to be pretty either. I guess put into the top one. 3 times 3 halves plus 2y equals 4 over 1. To get 9 over 2 plus 2y equals 4. Let's subtract the 9 over 2 from both sides. This side's gone. Over here, I'll just do it. Let's common denominator times it by 2 over 2. Let's show a little more work. I get 8 over 2 minus 9 over 2. 2y equals negative 1/2. I would try to get rid of the 2 here. Instead of dividing, we multiply by the reciprocal, which would be 1/2. These can reduce, and y equals negative 1/4. So that's our point, 3/2 and negative 1/4. Made more complicated by fractions, but the general idea is we know these cancel, add them, and then you can solve the rest. Don't forget to solve for x and y. The general idea is you want to obtain coefficients for x or y that differ only in sign. You always want them to be different signs because then they cancel out easily. That's a general idea. You can multiply either the top row or the bottom row or both rows. You just want to try to get one of the signs to be the same but different signs. And then you can just add them down, solve the rest. It's a general idea. Let's do another one real quick. We can get rid of the extra y's. We'll get rid of the y's that are already different signs. What I'm going to do here is I'm going to try to find the LCD for 3 and 4, which is 12. Multiply the top row by 4 and multiply everything in the top row. You're going to get 20x plus 12y equals 36. And we'll multiply the bottom row by 3 so that they match here. And we're going to add them up. Cancel. Get 26x equals 78. And then we're going to divide this by 26. And we get x equals 3. Nice. And we still have to find y. What you want to do after that is you can plug it back into any one of the original ones. Any one you want. Let's do the top row. So we have 5x plus 3y equals 9. But now we know that the x is 3. This guy is 3. So I get 15 plus 3y equals 9. Minus 15 from both sides. 3y equals negative 6. Divide by 3. And we get y equals negative 2. Our answer is 3 and negative 2. That's elimination in a nutshell. Okay, what happens when you solve? If you're solving two linear equations, you could either have one exact solution, that's where they cross. You could have infinitely many solutions, this one does the same line. The same line. Or they could be parallel. Two lines that never cross. Now the way we remember things are parallel, they have the same slope. And also, how do you know when they cross? They have different slopes. Let's see what happens when we have a no solution case. Same idea, we're going to try to get a variable by itself. In general, it's an x squared. You probably want to solve for the y. You have a quadratic equation. We're going to try to get the y by itself. Let's just add x to both sides here. And you get y equals x plus 4. And we're going to plug that in for the y over there. You get x squared plus x plus 4 equals 3. Same concept, we're going to try to get z equals 0. We have x squared plus x plus 1 equals 0. So that is prime. We can't solve that. The only thing we can do is quadratic formula, or complete the square. But our middle term is not even. I only complete the square if the middle term is an even number, because then I get nice numbers. So let's do quadratic formula just real quick. So there's our quadratic formula. X equals negative 1 plus or minus square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. Everywhere there's an A, plug in 1, because that's my A. Everywhere there's a B, plug in 1, because that's my B. And a C, plug in 1. And we get 1 minus 4. We do get an imaginary number. We have essentially negative 1 plus or minus I square root of 3 over 2. That's non-real. You get no solution. That's the no solution case. Okay, what happens when we graph it? Well, there's a couple possibilities. You can intersect at a point. We saw that earlier. If you do a parabola, you can intersect at 2 different points. Or they can not cross. That's what just happened here. We got an imaginary number, they did not cross. So this was solved by graphing. Now, we could do a sketch of this solved by graphing. We know how to sketch these, hopefully. Natural log. We'll have an asymptote at 0. Crosses at 1. Look, something to this effect. That's that one. And then if I graph this one, put in slope-intercept form. Y equals negative x plus 1. So you start at 1. Down 1 over 1. And then they'll cross right there at, well, in this case, I actually believe they cross at 1, 0. Something to that effect. That was an easy one, though. They don't always cross that nicely. If this was negative x, I wouldn't know where it crosses at. Let's do this one on the calculator. Here's my calculator. We're going to go to the graph, and we're going to type in natural log of x. This one, you do have to get y by itself. You notice it says y equals, so you have to get y by itself. You type it in the calculator, and it's a negative x. Notice I use the negative, not the subtraction, plus 1. It should be a standard window. I just turn it on, so it's standard for me. And you graph it. There's that line, and there's that line. There's the two lines. It graphs them in order, by the way. It graphs the y1 first, then it graphs y2. Anyway, we want to find the intersection. The way we're going to do that is put second trace, and then we're going to find the intersection 5. And what it does is, first, if you move it around, you can see it's on this natural log curve. It's on the first line. But you can also press up and down and switch it. Sometimes it's easier to move on the next one. And all they want to know is, like, hey, is that your first curve? It doesn't matter which one you pick. Put yes. And is this your second curve? Yes, that's my second curve. And then they want you to guess, and you put yeah. You just put enter. And it's a search to find the intersection. And I get 1, 0, like I did. This works better when it's not so easy, but it works the same. So that's our solution, 1, 0. Okay, finally, let's do an application problem. Total cost of producing X units of a product typically has 2 components. The initial cost and the cost per unit. If you think about the initial cost, this is going to be a linear question. Mx plus b. The initial cost would be our b. And the cost per unit, well, X is usually the unit. That's our slope. This is the cost per unit. That. How about something like that? That's what they're talking about. When enough sales have been sold that the total revenue equals the total cost, the sales are said to have reached a break-even point. The break-even point is when revenue equals cost. You've broken even. You'll find the break-even point corresponds to the point of intersection of the cost and revenue curves. Yeah, if you write a graph for revenue and write a graph for cost, the intersection, that's our break-even point, is this guy. Let's do an example real quick. A small business invests $10,000 into equipment to produce a new soft drink. Each bottle of soft drink costs 65 cents to produce and is sold for $1.20. How many bottles must be sold before the business breaks even? Let's do the cost equation first. This is going to be y equals mx plus b. Our initial startup fee was 10 grand. And it costs us 0.65 to produce. Y equals 0.65x plus 1,000, or 10,000. Our revenue function is just how much you're selling it for times x. The revenue function would be y equals 1.20x. Now, if I want to find the break-even point, we're just going to set these two equal to each other. Basically, going to solve it. Break-even point is this R equals C. So we're going to set this guy equal to this guy. You can think about it as substitution. This equals Y. We're going to plug it in for the Y right here. 0.65x plus 10,000. Yeah, maybe one too many zeros. Yeah, there are one too many zeros. Equals 1.20x. And then we just going to solve this. Subtract 0.65x from both sides. These cancel out. I get 10,000 equals 0.55x. And then we're just going to divide by 0.55. We get x equals roughly 18,181.8. Let's just round to the nearest soft drink because that's how many units we got to sell. We'll say that. That's our break-even point right there. So we got to sell about 18,000 soft drinks to break even. How many bottles must be sold to break even? This many bottles must be sold to break even. And that's the lesson.